to a lesson on the product to sum and sum to product trig identities. The goal of the video is to use trig identities to rewrite trigonometric expressions and also to determine function values. So here's a list of the product to sum identities. If you take a close look at them, you'll notice they look very similar to the sum and difference identities for sine and cosine, and in fact that's how they're derived. I included the product to sum identity here for sine. You'll notice that to obtain it you have to take the difference identity for cosine and subtract the sum identity. You may want to pause the video and look at this more closely. But we're going to go ahead and jump to a couple problems. Number one, we want to write each product as a sum. So we have the product of sine negative 4 theta times sine of 8 theta. So we have sine A times sine B. We're going to use the second identity. Let's go ahead and see how this works out. This will equal 1/2 times the quantity cosine A minus B, so negative 4 theta minus 8 theta, minus cosine of negative 4 theta plus 8 theta. And that's pretty much it. We have to simplify this, and we now have the product as a sum. Negative 4 theta minus 8 theta would be the cosine negative 12 theta minus cosine negative 4 theta plus 8 theta would be 4 theta. So we've taken this product and written it as a sum. Let's go ahead and try another. Here we have 2 times cosine 7t over 2 times cosine 3t over 2. Notice we do have a coefficient of 2 here, so we have to be careful with that. We have the product of two cosine functions. So now we're looking at this first identity where angle A is 7t over 2 and angle B is 3t over 2. So this will equal 2 times 1/2 times the quantity cosine of A plus B plus cosine A minus B. So be careful, we did have a coefficient of 2. These simplify out, and we're left with cosine of, this would be 10t over 2 or 5t. And 7t over 2 minus 3t over 2 would be 4t over 2 or just 2t. Again, we've rewritten this product as a sum. Here's another type of problem. We want to find the exact value of sine A times cosine B. So we're looking at this identity now. Let's see how this works out. 1/2 times the quantity of sine A plus B plus sine of the difference. So we're going to have 1/2 and the sine of, this would be 8 pi over 8 or pi. Here we're going to have 7 pi over 8 minus 1 pi over 8, that'd be 6 pi over 8 or 3 pi over 4. So now we need to find these function values. So the sine of pi on the unit circle, this would be the point -1, 0. Remember that sine is equal to the y-coordinate on the unit circle, so this would give us 0. Next, 3 pi over 4 would be here, and our reference triangle would be a 45, 45 right triangle, so we'd have 1, 1, square root 2. Of course, this is negative. So the sine of 3 pi over 4 would be opposite over hypotenuse, 1 over the square root of 2, which rationalizes to square root of 2 over 2. So we have 1/2 times square root of 2 over 2, which equals the square root of 2 over 4, which is the exact value of this product. So now we have the identities that take a sum and write them as a product. I've included the derivation of one of them, and again these are similar because they can be verified using the sum and difference formulas. So again, I would encourage you to pause the video and take a look at these to see where they come from. Let's go ahead and try a couple problems. We want to write the sum now as a product. So we have the sum of cosine A plus cosine B. So we're looking at this identity here, where our angle A is 9x and our angle B is 4x. So we have this will be equal to 2 times cosine A plus B divided by 2. Well, 9x plus 4x is 13x over 2 times cosine of A minus B divided by 2. Well, 9x minus 4x is 5x. And there it is. We've rewritten this sum as a product. Again, once we have these identities, there's not a lot to it. You just got to be very careful with the details. Okay, on this last problem, we want to find the exact value of sine 17 pi 12ths minus the sine of 13 pi 12ths. So we know that our angle A will be 17 pi 12ths and angle B will be 13 pi 12ths. So we'll be using this identity here. So this will be equal to 2 times the cosine of the sum of the angles divided by 2. Well, the sum of these angles would be 30 pi 12ths, which will simplify to 5 pi over 2. So we have 5 pi over 2 divided by 2 times the sine of the difference of the angles divided by 2. The difference of the angles would be 4 pi 12ths, which is equal to pi over 3. So we'd have pi over 3 divided by 2. Let's go ahead and simplify our angles. Remember, dividing by 2 is the same as multiplying by 1/2. So this would be 5 pi 4ths times the sine of pi over 6. Okay, we need to find these function values and then find the product. So again, we don't have our unit circle handy. Let's go ahead and sketch these in standard position. 5 pi over 4, there's pi, or 4/4 pi, so we need to go 1/4 of a pi more. This produces a reference triangle of a 45, 45, 90 right triangle. So we have 1, 1, square root 2. Of course, both the x and the y coordinates are negative. So the cosine of 5 pi over 4 would be negative 1 over square root 2. Rationalized, that would be negative square root 2 over 2. Now we need to find the sine of pi over 6. Well, pi over 6 radians would be here with a reference triangle of a 30, 60, 90. So we have 1, 2, square root 3. Everything's positive. So the sine of pi over 6 opposite over hypotenuse is 1/2. Let's go ahead and simplify this. Looks like we have negative square root 2 divided by 2 as the exact value of this difference. Okay, that'll do it for this video. Thank you for watching.